All right. Good morning, everyone. Welcome back to Math 154, Week 3, Lecture 1 on this wonderful January 26th morning. Reminder that you are responsible for reading ahead one section before a class. So we had finished 1.1 last time, so I had expected everyone to look at the notes to share for 1.2. We're also going to get 1.3 done today, but again, I only really ask one section from you, as well as the e-text. And again, I don't ask you to spend an hour or 2 hours reading the whole section. Just put your eyes on it, spend 5, 10, or 15 minutes just kind of seeing what there is, because quite often we reference the textbook or a lot of the notes are just pulled from it, even though you might not see it on the screen. Remember to practice stuff with Excel over and over and over. If you submitted that chapter 0 file and you feel like you didn't learn it, do it again. If you're working on this heart rate file and even though you get a 90 on it and you feel like you need more practice, do it again. Just keep doing this stuff until it is embedded in you. I don't feel like there is enough practice with my Math Lab homeworks and Excel homeworks for a lot of students. Remember, we talked about making an addition or multiplication table, even though I'm not going to grade that, and that is to practice using your fixed cell references, whether you're just fixing a row, just fixing a column, or maybe both, and that would be important for the 1.8 homework, which will be our third regular Excel homework. But the formula from that one's going to be a little crazier. You're not going to know what the answers are supposed to be. If you make an addition or multiplication table, you know what the answers are going to be. So if you use your fixed cell references wrong or not at all, then you're going to be able to say, does that make sense? Absolutely not. Homework due dates, 1.1, we said was due on the 31st. We finished that last time, as well as the heart rate file. Remember, there is a 6th hidden attempt for this one and only this one, so that's also due on the 31st. I'm going to show you how you can review your own work for the heart rate file in a couple of minutes. 1.2 and 1.3 will be finished today, so we're going to say that's due in a week on the 2nd. We will also assign a second discussion board. So in Canvas, you will see you have your general discussions at the top, then the week 2 lecture 2, and now you'll see a week 3 lecture 1. That will be due on February 2nd. Again, I don't always give a full week for discussion boards. I'm just kind of doing that initially while we're getting used to the swing of things. And as always, you're only going to answer one question. So far, everyone's doing a great job of that. I don't always have that every semester. So usually someone wants to come in and answer 50 things, which is why I have all these caps, cruise control, repetition. So again, y'all are doing a great job so far. I hope that y'all maintain that. But again, remember to only answer one question, not one question from each page, not one question from each type of thing, just one in total. And that if you don't have the opportunity to answer a question from the list, make sure you do it on the next one so that you don't get double zeroed. And we will always talk about the discussion boards during class. You'll always see the same instructions in Canvas for the discussion boards, as well as the due dates, pages, question numbers, etc. And these will always reference the guided activity book unless I specify otherwise. All right, so before we get into 1.2 and 1.3, I said I want to talk about how you can review your work with the Excel submissions, because some people have a harder time finding it, especially initially. So here's what you do. When you go into My Math Lab, you go in your grade book, and then you'll see all your grades, and you should see your Excel grades in there after you've submitted something and it says your grade is now ready to be reviewed, or whatever in the world it says after you do step 4 of that process. So I got a 33 on this because I have absolutely no idea how to handle Excel, right? Haha. No, this was intentional. I didn't even answer most of the questions because I don't want to give you all the answers. So you hit review. And then you'll come to this screen, and then you'll click this spot right here, just like when you go to download them. And it'll give you this little warning that you're just reviewing. If you try and change anything in here, your score is not going to change. You hit continue to review. And you have 2 different ways you can review it. One is on this screen, and the window can be a little goofy depending on your browser. You can maximize it and maybe the whole thing will show up. And you can see, all right, all these different layers, all these different rows and columns. Step 1, what the points possible were, whether you got them or not, will be seen on the other screen. So 0, 4, 4, 4, 0, and then 12 total. So the first way you can check your work is you can scroll down here and hit questions. And then you can see this is basically what my Excel file I submitted looked like in terms of just the answers. It's not showing the formulas or anything like that. I didn't actually submit the chart. I didn't submit any answers for ages 20 through 100. I did submit an answer for age 10, but it was wrong, or at least whatever I typed in was wrong. All right, well, I got this one right. And if you hit a check, it tells you exactly, if you hit that check mark, it tells you exactly what you did right, the points you got right, et cetera, et cetera. The ones I got wrong, same thing. If you click the X, pulls up this little screen, and it tells you, unfortunately, a little too detailed, in my opinion, exactly what I did right or wrong and that I got 0 points out of it. Same thing here. And it doesn't say I didn't type anything. It just says I didn't type that formula, blah, 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 blah. So this is fine, but you keep having to hit these little sub menus. It's kind of tedious. What I prefer to do is just to go at the top, right to the right where it says submission ID, download, open that file, play the waiting game. We're gonna open. Here we go. Make sure you hit enable editing. And then you'll have 3 screens. It'll show you where you lost your points, all that jazz on the submission markup, the instructions, which is going to be the same, but here's where you want to focus on, the questions tab. But it's no longer just questions. You'll have red spots for wherever you did something wrong. And if you hover over those cells, it'll tell you exactly what you did wrong. So these are the same statements on that other screen, but instead of having to click and open up a submenu, I just hover over it. It's a lot quicker. So this is the way I prefer to do things. Now, this doesn't tell you exactly how to do everything. It just says what you did wrong. So admittedly, and I mentioned this in class, all you really have to do is type something here and then fill that formula down. So what some students will do is go through and manually type, oh, well, I didn't type this thing, so let me type it there. Let me type it here. 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 And they're going to get a good grade, but they didn't actually learn the process. Because imagine I had this for 1,000 different rows, and then you had to go and type it in for 1,000 different rows. No, you should have just typed it into the first one and filled the formula down. And if you look up here, you can see what I had typed myself. So even though my answer here is actually right, because whatever I have typed here is wrong, and it says you did not type something, it did not give me credit for. So again, even though numerically the answer is correct, because I didn't use a cell reference, it's wrong. And some students will get this one wrong because they don't have the formatting wrong. It talks about using a specific number of decimal places. It talks about using this little drop-down menu to format it a specific way. And I left the chart completely blank, so it's not gonna, it doesn't give me any grading for that. I don't even remember if that one does count as a grade or not for this one. Sometimes they do, sometimes they don't. But anyways, I didn't want to spoil too much there. So that is how you can review your Excel homeworks to then get a better second submission, a better third submission. Sometimes these things are just super wacky, and even though your answer is right, it'll tell you you're wrong. If it's only one question, it's only knocking you 5 points. If you've got like a 94 or 95, don't sweat it. Remember, you're going to get that 10-point boost in your Excel grades as long as you have earned a passing grade to begin with. But yeah, sometimes the grading is really wacky, and it's usually only a few points that it'll take from you, which won't make any difference at the end of the day, since I give you that little boost. I didn't used to give you the boost, but the auto grader got weird a semester or 2 ago, so that's why I do it now. And if there's ever a case where people are losing like 20 or 30 points, I'll go through and adjust grades manually, but just remember in my own grade book, it's reflected. And no, I'm not going to show anything on how to do this. You have to figure that out on your own. That's why it's homework. So with that being said, reminder, due dates, you'll see it at the end. January 31st for 1.1 and Excel heart rate 1.2 and 1.3, which will finish today, are going to be 2.2. The new discussion board will be 2.2, as well as the previous discussion board we assigned was going to be due on the 31st as well. I just didn't have that on screen. All right, so let's go ahead and get into today's lecture.
And that review is this right here, something that we saw in the that $1,000 TV loan problem we were working on, that we needed fixed cell references for that one. And the reason was because whenever you fill a formula down or right or left or up in Excel, whenever you type that formula once and then you want Excel to apply it to 10 or 50 or 1,000 different cells, as you're dragging that formula down, as you're filling it down more specifically, or right or left or up, whatever it is, Excel is going to assume that you want the cell references to adjust accordingly. In other words, if you're moving down, that you want the cell reference to move down with you. If you're moving right, that you want the cell reference to move right with you. But this isn't always the case, once again, as we saw in that flat screen problem, which I will pull up for a very brief moment, and I'm going to fill it out super quick. So we started out with the balance. We're going to link it to where the principal is. We said that the interest is just the product of the balance, so equals balance times the APR. But because the APR is over here, kind of odd man out, odd woman out, whatever you want to say for the phrase, when I'm dragging this formula down, the blue box, you will want to be moving down to month 2's balance, to month 3's balance, to month 4's balance. But you don't want this one to move, because if it moves down, this is blank and the APR is not 0%, or sorry, not APR, this is the periodic rate. The APR was the 12%. We're multiplying by the periodic rate. I'm just talking too fast. Sorry for that. But again, when you fill it down, this red box will move down, and you don't want it to move down. You want it to stay put. So that's what it means to fix a cell. It doesn't mean to fix a broken cell. It means to fix it as in to make it stay put, to not move. It's fixed. It's rigid. It can't move. And some of the references make it so you can't move them left or right. Some of them makes it so you can't move them up or down. Some of them makes it so you can't do either. And it turned out for this one, technically you only have to fix it so it doesn't move down, but we said, just since we're starting it out, see when I try and use my arrows, it's moving the cell. If you look at the right here, F6, G6, H6, I was trying to move left and right, but Excel did something I didn't want to do, so I hit enter, and maybe I have to hit undo, or I just go back and double click. And we said what you do is you put cash signs in front of the number and the letter and the number. When you do this, it makes it so, since I'm doing this on the red cell reference, this cell will not move at all when you're filling a formula left, right, up, or down. So I hit enter, I get the answer I expect of $10. The new balance is the sum of the balance plus the interest. I could have used sum, but because it's only one or two things, this is a shortcut. And we're getting answers that make sense. We said that pretty much anything like this, when we're doing interest and adding or subtracting to a pile of money, you'll have to do 2 complete rows before you can fill everything completely down. And that's because in month 2, you have to link the new month 2 balance to the starting balance of month 2 to the ending balance of month 1. It's a better way to phrase it. So we go equals, and then we just link it like we did the starting balance to the principal. Enter. Then I can drag this interest formula down by filling it down. And if I double click it, you can see that the blue cell is exactly where it should be, and the red cell is exactly where it should be. The blue one moved down because there's no caches, but the red one stayed put because it was completely fixed. So caches in front of the letter and the number will, hold on, there we go. Caches in front of the letter and the number will fix both of those references. It makes it so it doesn't move down, left, right, or up, but only on the one with those cache symbols. So again, you can see that the blue one does not have the cache symbols, so it will keep moving down. But the red one had them, so it doesn't. Let's drag the new balance formula down, and then I can just highlight all 3 of these, grab the fill handle, and take this all the way down to month 12, and we get the same answers that we saw before. And if I double click any of these interest formulas, you can see that the blue box moves down to the appropriate month, but the red one does not. If I had done this wrong up front, if I had made this no cache symbols, just G6, and then if I fill this formula down, the rest of them say an interest of 0, because when we double click that cell, you can see that the red box is moving, which we didn't want. The red box is moving further down. We didn't want that. We needed it to stay up here. So this is one of those things you'll have to practice with. So let's see, do I want to do this first? Yes. I'm actually going to go ahead and mention something from later in the notes. It's the end of notes, but because this actually goes more in line with what was given to us at the end of 1.1, let's go ahead and do that. It's just something I should rearrange in my notes to share. This shouldn't be at the bottom, it should be at the top. So make a multiplication table before trying out 1.18, this Excel file 1.18 BMI. This is going to be, I believe, the 3rd Excel homework you have to do. And I'm going ahead and referencing that this is going to be an issue for all of us. This is going to need all three types of these fixed references, or at least two of them. You can argue that the homework needs all three. The multiplication table only needs two of them. So we have got to learn when to only put a cash symbol in front of the letter and when to only put a cash symbol in front of the number. Because again, in the instance we just had, we were only filling a formula in one direction. There's generally not this complexity to it when you're doing that. It can be, but not always. When we have to fill a formula right and down, or left and up in the rare instance that we do it that way, very often these two issues come up, that you'll need one of the cell references to move left or right, but not up or down, and then you might need another cell reference to move the exact opposite way, up or down, but not left or right. And this bold statement, I bolded it because it's super important, because it can help you. When you're filling a formula to different rows and columns, like you're trying to make a multiplication table, any data from a column must have the column fixed, which is the first one, where you put the cash symbol in front of the letter. Putting the cash symbol in front of the letter, remember the letters represent the columns. Here's your Excel. The letters represent the column. So putting a cash symbol in front of the letter makes it so you don't change column. Columns, you can go up and down, but not left and right to stay in the same column. So when you put a cash symbol in front of, say, D, it can still move up or down, but it won't move left or right. And I will show you what I'm talking about. But vice versa, any data from a row must have the row fixed. So when we want to stay in that row, rows are horizontal, rows are completely horizontal. So if we don't want to move out of this row, we need to make sure we're not moving it up or down. So staying in a column means we don't want it moving left or right, so we fix the column. Trying to stay in a row means we don't want to move up or down on the reference, so we fix the row or the number. So I'm going to leave this up here for just another 15, 20 seconds, and then I'm going to make that multiplication table myself, and then I'm going to ask you to reproduce it. Now, I'm not going to make you submit this to me like the chapter 0 thing. I don't want to get into that. I just need you to understand how important this is. You, the student, absolutely, positively must make an addition or a multiplication table. I'm going to make a multiplication table, but an addition table would work fine. And then I would suggest that you do that 2 or 3 or 4 times before you go trying to do the homework for 1.8. And the reason is the homework in 1.8 has got a formula that's got a little bit of pizzazz to it. It's not just this thing plus this thing or this thing times this thing. It's got a product and an exponent, and it's going to need a parentheses, and it's going to have just a few more complexities than what we're about to do. So why would you want to have to learn this idea of fixed rows and fixed columns on top of using a complex formula and getting answers that you might not necessarily know what they should be? Why wouldn't you want to just take a much simpler approach, create what I'm about to do, this multiplication table, where you know what the answer should look like? Or an addition table where you know what the answer should look like, and it still helps you understand this idea. So this is us making a multiplication table that you will do as well. Now, how big of a multiplication table do you need to do? Honestly, a 3x3, a 4x4, a 5x5, that would get the job done. I'm going to go 10x10 because that's just classic multiplication table. Some people go 20x20 or 13x13, whatever. So multiplication. Just going to widen that so the word can be seen completely. So what am I going to be multiplying? I'm going to be multiplying the numbers 1 through 10 by the numbers 1 through 10. And the way we set this up is we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, I could have just typed 1, filled it down by holding control, and it would have incremented the numbers, or I could have typed the 1 and 2, highlighted both of those cells and filled it down, and it would have given me the up to 10. So if you were going to do this with, say 100 numbers, that's the way you would have wanted to do it. I can go for the top part, not or, I can go 1, tab, 2, tab, 3, tab, 4, tab, 5, tab, etc. You don't have to use tab. You can use your mouse and click, but it's going to be much slower. Now, you Our quantitative reasoning students, you were supposed to have passed out of what we would have called back in the day being a semester ago, developmental math. Whether or not you actually have done that, I can't say anymore because of these multiple measures and et cetera, nothing we need to get into, but this is something you definitely should have a skill of in this level. So you should know the fact that, all right, this cell right here should be 6 times 5, which 6 times 5 is 30. So the ultimate answer in this block should be 30. Now, before I move on, I'm actually going to emphasize these by bolding them. So I'm going to highlight and hit B, highlight and hit B. Maybe you even want to color code them. So maybe you highlight them and make the colors just say, hey, these are the columns. These are what we're multiplying by. So you could do that times that, yellow, gray, whatever. I'm going to skip the colors, though, because I want to be able to see the cell references very cleanly. So you only have to type one formula ultimately, if you get it right on the first time, which we will not, spoiler alert, and then you could fill it right and fill it down and you'd be done. And that formula should just be equals without appropriate fixed cell references. So if I'm in this cell B2, that's the 1 times 1. Now I don't type 1 times 1, I want to do cell references. So I can click or type cell A2, then the multiplication symbol, which is that star, and then click or type cell B1. And the blue and the red show me what we should be multiplying. Yes, that's definitely the 2 cells we should be multiplying. So I hit enter, and 1 times 1 is 1. Awesome. Okay, well, since that one worked, the rest should work, right? Question mark, inflection and voice, hint, wink, nudge. So when we have, I can't just grab the cell and do that. That doesn't fill. You have to activate it, hover over the fill handle, click and hold, and drag down. So if I drag down all the way, let's see what we get. Does that look like our multiplication table? Absolutely not. 1 times 10 is not 3,628,800. 1 times 10 is supposed to be 10. So if you double click on any of these wrong answers, you will probably see a blue or a red box in a wrong spot. Let's click on the 50/40. Double click. Now remember, if you're in this row, you should be multiplying the bold numbers. The bold number in this column, so the 7 times the bold number in this row, the 1. This should be 1 times 7, which should be 7. But like we saw, it's 50/40. Because when we double click, the blue box is in the correct spot, but the red box is not. So what this tells us is the blue reference, we do want to be able to have it moving down because we want it moving down parallel. So if I hit enter, if I double click on this one, we should be using the 8. It's moving down appropriately. The blue box is moving down. The blue box is moved down. So the blue box is okay so far. Hint, wink, nudge, it's not right ultimately though, but it looks right so far. But the red boxes, when I click them, the red boxes are supposed to be up here, and they're not. They're just one above where our formula is currently located at. That's a problem. So what we need to do is fix the red box so that it's not moving up or down. Now, I'm going to do it wrong first. So let's undo all of these. Let's just delete all these. Delete. Sorry. Delete. I hit home on accident, not the delete button. Let's double click where we had our formula. And we know the blue box we wanted to move down. Let me show you how I can screw that up. So I'm doing this wrong. We want the blue box moving down. We want it going from row to row. But if I put a cash symbol in front of its number, this fixes the row. This means the formula will be stuck on row 2, but only for the blue reference. The red one's not fixed. It's not stuck. So we're stuck. That's what this cache 2 means. We're stuck for the blue reference to row 2. So I hit enter. That looks okay. But when I fill it down, now these answers still look wrong. I wouldn't say worse, but I wouldn't say better. Because look, the blue box is not moving down when we wanted it to. The red box is still moving down. The blue box is not moving down. This is awful. So how did I say we learn how to do things in Excel? We do them wrong, and then we do them right. So let's just undo, 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 double click. Let's get rid of that cache symbol. So we said, so far it seems like the blue reference is fine. Let's adjust the red one. Hopefully you don't have a black and white screen. So the red one is the one that we don't want moving down. If we don't want it moving down, we want it to stay to the same row. The numbers tell you how far up or down it is. And I know it feels counterintuitive at first. You know how you fight against counterintuitive things? You do them over and over and over. So the row tells you how far up or down you are, because this is row 2. This is row 11. So if you put a cash symbol in front of that 1, it's going to stick to row 1. Again, I'm going to do this wrong though. Let's put the cash symbol in front of the letter. So I'm going with my initial wrong intuition. I'm going to say put the cash in front of the letter. All right, well that one's right, so let's activate it, fill it down, and still wrong answers. If you double click, you can see that the red box is still moving down, which we wanted the red box stuck where it says that bold 1. So undo, undo, double click, not a cash symbol in front of the letter, it's in front of the number. All right, I did it wrong. I never even learned how to do this officially. I didn't memorize it, but I tried it out and I'm seeing that, okay, put it in front of the number, activate, grab the fill handle, fill it down. Holy cow, it's finally right in appearance. Still not ultimately right completely, but it looks better now. This looks right. If you double click on any of these, the blue reference is correct, the red reference is correct. Enter. Double click, correct, correct. Because by putting a cash in front of the 1, it makes it so this cell will not move down. It still has the ability to move it left or right though, because I don't have a cash in front of the letter. So again, the cash symbol makes it so it doesn't move from that row or letter, whichever it's in front of. If you put it in front of both, it doesn't move either way. So now that these are correct, let me highlight them. And what it seems like is I should be able to now just fill this table to the right. And that everything should be correct, and it's not. You even get some really wacky looking answers on this far right column K. It says 10 times 10 is 3.6e plus 7. This is what we call scientific notation. So that's 3.6 times 10 to the 7th. That's what that symbolizes. E plus 07 means times 10 to the 7th. Basically, where this 3.6 is, where the decimal is, move it right 7 times. So it would be a 3, a 6, and then 6 zeros after that. So 36 million. But it's not exactly 36 million. There's some rounding involved with the display, but don't worry about that because it's wrong. So if I click any cell, now this cell right here should be taking the 3, so the blue box should be around the 3, times the 6, the red box should be around the 6. Let's see. Nope. Now the red box is actually okay. We did want the red box moving, so putting a cash symbol in front of its letter would have been wrong. But now the blue box is moving right. We didn't want it moving right. We want the blue boxes able to move up and down along these bold numbers. So we want the blue ones moving up and down, but we don't want them moving right because then you're actually going into the answers. That's the exact opposite of the red ones. We don't want the red reference moving up and down because it goes off of the bold values, the ones we're using to calculate. But we do want it able to move left and right. So let's see if we can fix this, pun intended, sorry. So we got to go back all to where it was just the single formula, no numbers anywhere else. Let's see, do you think I'm going to do this wrong first? Hint, I'm going to do it wrong first. So the red box was moving correctly. We saw that. Let's do it wrong. Let's say, oh, I'm just going to try this out. I'm trying everything. So I double cached the red reference, which means in front of the letter and the number. So if I do this, that still looks okay. But when we do this, that looks terrible. That says that all the products are 1 through 10. So the blue box is moving, which we don't want. And the red box is stuck over here, which we also don't want. So this is terrible. This is actually the worst we've done so far. So we definitely didn't want to do that. So we undo. So don't put a cash in front of the letter because we want it to go from B to C to D to E to F to G for the red reference. Let's do it wrong for the blue one. So we said we want the blue one moving up and down, but we don't want it moving left and right. So maybe I think that putting a cash symbol in front of the number will fix that, adjust that. So oh, that actually looks wrong where it was right before, and that looks just as terrible. So that must have been wrong. You can double click on any cell and see that the blue reference is not in the right spot, but the red one is. The red one looks good. That means its reference is probably good if you're in another row or column besides the first one. So we still got to get the blue one right. So maybe instead of putting the cash symbol in front of the number, we put it in front of the letter. Undo, 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 double click. So instead of the number, let's put it in front of the letter. reference. Again, putting it in front of the letter makes the letter not change. We don't want the letter of this blue one changing. We want it stuck in column A. Now when I fill it down and right, that looks good. And holy cow, we got it. That looks good. So I am giving you a complete spoiler for this, just like with that chapter 0 homework. That's the formula that goes in that cell for multiplication. If you wanted to do an addition table, this would just be a plus instead of a times, and then everything is still the same. But this, again, is for emphasis on when you have a full set of row and columns for a table of values that you're processing with some formula, which the 1.8 BMI homework will do to you. But the 1.8 BMI homework, its formula that you're doing isn't just this thing times this thing. It's like this thing times this thing over parentheses, this thing times this thing squared. It's something like that. And there's a preview of it in your guided worksheets. You can go ahead and download the homework since you know what's coming up. But I am telling you, make this before you even try and tackle the BMI. Because if you can't make this, you are not going to get the BMI formula wrong, and it will cause a lot of chaos. So do this, then do it again, then do it again. So do this, close it out, don't even save the file. So don't save. Then do it again, multiplication. 1, 2, let's do this quicker. Highlight both of those, grab the fill handle, drag it down, boom. 1, tab 2, highlight both, grab the fill handle, move it 3, 4, 5, 6, 7, 8, 9, 10. There we go. Formula spot equals to make it a formula. Now usually most people don't start with the cash symbols first. So this thing times this thing. Hit enter. Highlight, fill. Oh, those look terrible. So then you undo, double click, go back and get the cash symbols adjusted. Let's see. I'm going to get this right on the first try this time. So I know with this blue one, actually before I do that, let me bold. I'm doing Control B this time, mixing things up, Control B. So for this one, the blue one, I want it to move up and down. If I want it to move up and down, that means I want it going between rows 2 and 11. So don't put a cash in front of the 2. But I don't want it moving left and right. So if I don't want it moving left and right, that means I don't want the letter to change. So cash in front of the letter for the blue box. That is correct. For the red one is up here. We want it moving from column to column to column, so we don't put a cash in front of the column. But we don't want the red box moving down into this region, so that means we don't want it to change row numbers, so we cache the row. Highlight, fill, boom, there we go. Completely correct again. You can color these things if you want. I don't care about the painting. Again, you are not going to turn this into me. You were just creating this for your own practice for the point of an actual homework coming up in, a week and a half, 2 weeks, something like that. Okay. No cash symbols means the box, the blue, red, whatever color box for the formulas, when you use a cell reference, they can move however they want to. Putting a cash symbol in front of the letter makes it so that cannot move left or right. Putting a cash symbol in front of the number makes it so you can't move it up or down. Putting a cash symbol in front of both of them fixes both. It means that red or blue box will not move at all. There are times when we need that, like when we were doing this one, because this box was just randomly out to the side somewhere. We don't want, for this formula, we don't want that red box moving right, nor do we want it moving down, which is why we really needed the cash symbol in front of both of them. And I can fill it down, and we get our correct answers. By the way, I was actually really impressed with how many people got the APY correct for that discussion board, so excellent job there. Okay, so let's get off of Excel for a little bit. Kind of, we're still going to talk about it a little bit, but in relation to just some straight up math. So officially getting into 1.2. And this is just going to be kind of more heavy math section, rediscussing PEMDAS, order of operations, a couple examples involving that. getting into a crazy Excel formula that I am not going to have you do as part of the guided worksheets. Yeah. So order of operations. I know some of you have heard me say this already if I didn't do this to the general class, if I just did this for the MTE class, but order of operations, this is where people go on social media and they just love to say that they are absolutely correct when they're doing something wrong. Classically, people mess up the order of operations because they see PEMDAS, they see 6 letters, they think it's 6 steps. They think, do the parentheses, then do the exponents, then do the multiplication, then do the division, then do the addition, then do the subtraction, and everything I just said was wrong, 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 wrong. There are only 4 steps to PEMDAS. There are only 4 steps to the order of operations. P, parentheses, that's your first step. E, your exponents, that's your second step. Multiplication and division together from left to right is your third step. So what that means is you don't do all the multiplications and then all the divisions. You don't do that. If you see a multiplication, then a division, then a multiplication, then a division, you will do them in that exact order. If you see 10,000 divisions and then a multiplication, you would do the 10,000 divisions first and then the multiplication. There's only 4 steps. The same is true for addition and subtraction. I see pre-developmental math students do this wrong. I see developmental students do it wrong. I see quantitative reasoning students do it wrong. I see pre-calc students do it wrong. I see calculus students do it wrong. I've seen teachers do it wrong. Hey, admittedly, I've even done it wrong once or twice because I was rushing. But I always catch myself and fix my mistake. Excuse me. Sorry if that was loud. When you see a parentheses, if you just have a negative number, for instance, surrounded by a parentheses, or even a positive number, that doesn't count as a parentheses. A parentheses means there's stuff going on inside of it, like this 3 minus 4 right here. So a parentheses counts as a parentheses when there's things going on inside of it. There's other things that count as a parentheses. Absolute values count as a parentheses. Square roots count as a parentheses. And then there's other things we don't need to discuss. Logarithms, we're not going to be doing logarithms in this course. So, addition and subtraction, same thing. If I saw a subtraction, then an addition, I would do them in that order. So multiplication and division are opposite sides of a coin. They are the same step. Addition and subtraction are opposite sides of a coin. They are the same step. Don't do additions and then multiplications. Don't think that you're just doing all of them from left to right. You do these 2 in a pair from left to right, then you do these 2 in a pair from left to right. This is not something we're teaching in this, that we're reminding you here of this. So if you are rusty, if you're getting this wrong 50 times, it is on you to practice over and over and over, to go to resources online, go to tutoring, anything like that. We're supposed to be above that, but I remind you. Exponents with negatives. So this is a very important, not application, idea. Let's say idea throughout the semester that can come up a little bit here, a little bit there, whatever. So what's an exponent with a negative? What are you talking about? Well, we're talking about this -2, I'm sorry, I want to make a -3 as the base. -3 as a base and parentheses squared versus -3 squared without a parentheses. So these are 2 completely different problems that are handled completely different ways. The way exponents work is they apply only directly to the thing to the left of it. So this -3 squared is wrapped in parentheses, the red one. So the -3 counts as being applied to the exponent because of the parentheses. The parentheses comes first. So this whole thing is a -3, and you're multiplying it by itself twice. But this blue version, this 2 does not apply to this negative. This does not apply to the negative. You are only squaring the 3 and then the negative just comes along for the ride. Because this minus counts as a subtraction ultimately, and an exponent comes before a subtraction. No, it's not actually a subtraction the way it's written, but that's what it counts as. So when you do this, the first one is -3 times -3, which is +9 because two negatives cancel. But the right-hand version, the negative is not repeated. It's just the 3 that's repeated. So the negative, this negative is this negative. And then the 3 squared is this 3 times 3. Again, the negative was not part of the blue version's exponent, so it is not repeated. And this is a negative times a positive, which is a negative. Now, what's interesting is whether these exponents are even or odd actually makes a drastic difference in whether they have different answers or not. So let's do -2 cubed versus -2 cubed, one with, one without. And I'll do this quickly. The first one, the negative repeats. -2 times -2 is +4, excuse me, times the -2 at the end, and then 4 times -2 is -8. But the blue one, the negative is not repeated. It's just the 2 cubed that is, 2 times 2 times 2. -2 times +2 is -4, times +2 is -8. Again, this is a review technically, but I know everyone needs to see this, or almost everyone needs to see this. So while with the even exponents, you do get different answers, with the odd exponents, you get the same answer. But how do you know whether you're going to always have even or odd exponents or if it's going to be a mixture? Well, guess what? It's going to be a mixture. So you have to understand this. Half the time you'll have odd exponents, maybe. Half the time, maybe you have even exponents. It's not exactly half the time. I'm just saying it's kind of like flipping a coin. So yeah, when they're odd, you'll get lucky. You can actually screw it up and still get the right answer. But when they're even, you have to get it right. Now, if you're programming something in Excel, a formula that's supposed to deal with all exponents, if you program it wrong, you're going to have half the answers right and half of them wrong, which means ultimately you've got it wrong. So make sure you understand the difference here. This is drastic. And again, I see math students of all caliber mess this up. So I even remind my calculus students of this. But again, I tell them, hey, you're supposed to have this down, so we're moving on. And quantitative reasoning students, you're also supposed to have this down, so we are moving on. 4 steps in Pemdas. Exponents with negatives, a parentheses versus not having a parentheses. It matters whether it has it or not because it will tell you whether to repeat the negative or not. How about this? Math form versus Excel form. This is really just kind of an algebra review section for the most part, but with a little dash of Excel use thrown in. Sorry, give me 10 seconds. Okay. Math form versus Excel form. So this 3 minus 4 in parentheses /7 plus 1. This is kind of like something that would be seen in Excel form. This is, you can still argue, some people would argue this is still a math form, but this is how things look in Excel generally. So this is how something would look in Excel with an equals in front of it if you actually want Excel to do the thinking for you. So that's Excel form. The math form of this would be 3 minus 4 on top of a 7 plus 1. This is the, quote, math form. These two things are equivalent to each other. Why am I showing you this? Because very often you will have to take mathematical functions, formulas, equations, expressions, anything like that, and put them in Excel. So you'll have to know how to take something that looks like this and make it look like this. Spoilers, that 1.8 BMI, this will be part of that problem. It's not just fixed cell references that are going to be a complication. It's knowing how to put things in Excel form. And I'm going to show you a very, very ugly formula that is a very, very ugly Excel form as well. But it's something we won't really mess with until the end of the semester. But let's hold off on that idea. So most of the time for this course, you would be looking at this and you would need to turn it into this for like a homework problem. It's not something that's going to be a common issue in class or in your My Math Lab homework, but this will be common for Excel because you'll have to be doing formulas and taking this and turning into that, but with cell references. So this 3 minus 4 is on top of a fraction and you want to divide it by the 7. So if I just wrote this, if I wrote, let's do red for wrong. If I wrote 3 minus 4 slash 7 plus 1, without the parentheses around the 3 minus 4, this would be equivalent to 3, then a minus 4 over 7, then a plus 1. Now, I'm not saying the red to red is wrong. I'm saying that this would not be the same thing as this, or this would not be the same thing as this. This is just a different problem. So maybe not even call it wrong. Just say different problem, since I'm showing both versions of it. So what's the major difference here? When you have this 4 over 7 by itself, you just do 4 slash 7. This counts as division in Excel. But if the 3 minus 4 is all on top of the fraction, so that you will do the subtraction before the division, because this is a subtraction, this counts as a division, to make sure that this gets priority, you have to wrap it in a parentheses in Excel's version, because there is actually an implied or hidden parentheses around this. Tops and bottoms of fractions count as parentheses. You have to condense them all into a single number before moving on and trying to reduce your fraction or divide the fraction. So there's a major difference in these two things. And I'm actually going to go over the guided activity on page 37 completely because I want to make sure that we get these answers right. It's very easy for a discussion board to go sideways with this, I think. So let's take this idea and go with it to page 37. Page 37. 37. Here we go. Now let's do this. Actually, I don't want it on the same document. Go. All right, so guided activity number 1, page 37. Try and follow along with this. For each of the following, compute using proper order of operations. So some of these I'm going to save, some of these I won't. It's these top ones that I am going to let y'all do, but it's the number 2, A, B, C. I thought there was a D for some reason. Nope, just an A, B, and C. So we're going to do these. I'm going to leave these for y'all. So for number 1, A through E, A through E. This will be part of your discussion board. 9-8. So 1 student each initially. Remember, if someone does it wrong, another student can come in and say, well, I did this and got this answer instead. And then maybe a third student can come in and say, well, I agree with person A, I agree with person B. But I don't want any one student doing all 5 of these in the discussion board. Can you do them on your own in your own notes? I would highly encourage that. But for the discussion board, please only do A or B or C or D or E. So we're going to focus on 2. A. So write down how you would type these in Excel as a formula. This is 2 plus 4 all over 3 times 6 and then minus a 6. So when you have extra steps in the top or bottom of a fraction, that's a good sign that you need a parentheses around it. Now, the first thing you have to do for a formula in Excel is always type what? That's right, equals. So equals. Now, because the 2 plus 4 is in the top of a fraction, I'm going to go parentheses, 2 plus 4. Without the parentheses, when I do this slash for my division, it would think just the 4 was the top of the fraction. Now, the 3 times the 6 is in the bottom of the fraction, so same idea. Let's put 3, and then use the star for the times, because that's how you would have to type it in Excel, 3 times 6, and close the parentheses. The top of the fraction, parentheses, division for the fraction. Bottom of the fraction, parentheses, because of the extra numbers and everything. This minus 6 is to the side of it, so just a minus 6. That's it. B. So we're doing this in Excel, so the first thing we type is equals. That 5 is isolated and by itself, so just a 5. And we have a plus sign. Now the 2 is the top of the fraction. There's nothing else going on with it, so I don't need a parentheses around it. I could put a parentheses like this and it's not wrong, but it's just extra things that we don't need. Extra things tend to make us make mistakes. So then the fraction bar counts as our division. Now there is a bunch of stuff going on in the bottom, so we will need an open parentheses. Heck, it even has one in there for us, kind of demonstrating that. And in that parentheses is an 8 times 4. Then it closes it. And then we have an exponent of 3 plus 1. Now your exponent key in Excel looks like this. It's an upside down V, and that is Shift 6 on your standard keyboard. Now I'm going to do this wrong for a second. I'm going to pull out the red for wrong. The exponent, if you can't see, if it's too small, that's 3 plus 1. Red for wrong, red for wrong, red for wrong. Why is this wrong? Because this says the exponent is going to only be the 3. This exponent is only applying to the 3, and then the plus 1 counts it as out to the side. So that would be like this plus 1 is no longer the exponent. It's kind of like the 5. It's just another number being added. So to make sure that the plus 1 is part of the exponent, and this will be a theme that pops up throughout the semester, you need to wrap it in parentheses. 3 plus 1. Now you might say, well, Mr. Beckner, why not just write 4 because it's 3 plus 1? I like the idea here for this problem, but we're usually doing Excel references, so this is probably like cell C3 and cell D3, and you wouldn't just be able to say C3 plus D3 is Q19. I don't know. You wouldn't want to do that. So when you have complicated exponents that have pluses, minuses, anything like that, you need to wrap them in parentheses. And that was it. C, it's an Excel formula, so don't forget the equals. You forget the equals, it's wrong, and that would suck. Again, this one kind of has the parentheses already in place, it feels like, but it's actually not good enough. So let's do this wrong at first. So some students would go, oh, parentheses, 9 plus 2 / 8 minus 11, and I'm going to stop here. We're already wrong in 2 spots as well. Because this fraction has got the 9 plus 2 in the top, but because the 9 plus 2 isn't in its own parentheses, this is the only thing that's the fraction. This is 2/8, and then a 9 being added to the left of it, and a 11 being subtracted to the right of it. This red does not look like what C started out as. So that was wrong. So that says we were supposed to have, so here's the parentheses for the whole fraction. 9 plus 2 / 8 minus 11. That outer parentheses is the one seen in the example. But to make sure the 9 plus 2 go on the top of the fraction, I'm going to need, and I'll pick a different color. Let's go with green. This extra parentheses to make sure that's the top of the fraction. And you also need one around the 8 minus 11 to make sure that's the bottom of the fraction. Then we have this 4 times 6 as an exponent, so we'll need the caret. That's what that symbol is called, the upside down V. If I do this, it's wrong. I'm not going to pull out the red again. First of all, it's wrong for 2 reasons. I made a plus sign instead of a times. I did that intentionally. I did that incorrect in a class last week, unintentionally. So I wanted to make that mistake intentionally right now, but I'm not going ahead and make it. So that was supposed to be a times, so that's wrong. And also, this says the exponent is just the 4, and it would have a times 6 way out to the side, like how that minus 1 is. So for times 6 wrapped in parentheses, that takes care of the whole fraction, so then we can just go minus 1 to the side. So again, so far right now, all I've given is 5 questions. I'm going to scroll down quite a bit. Oh, I wish I had the answer one pulled up. That's okay. So here's that BMI Excel preview I mentioned from earlier. This is the formula you'll be typing in an Excel. It's got a product in the top, it's got a product in the bottom, an exponent in the bottom. It has one parentheses there, but spoiler alert, you're going to need more than one parentheses for this whole problem. And this is the thing that you're going to need: fixed ref rows and fixed heights, or excuse me, fixed columns. Height was a poor word choice there. One of these two things will need the row fix. One of these two things will need the column fix, just like with the multiplication table. So practice the multiplication table before you try doing this. Now with that, they don't give you as many kind of hints and answers as the heart rate did. But it does at least give you a couple here, maybe not, maybe not. So 27.2 computed body mass index with this height in inches and this height in, this weight in pounds. So using the 62 and the 145, this is what the answer should be. So that should give you a helpful hint when you're working on that Excel homework. Okay. The last thing I really want to show you for now in this that I'm going to cover, this is what I was alluding to earlier, the crazy formula that we won't deal with till the end of the semester. This is the payment formula for a car loan or a mortgage, which is a house loan, or a boat loan, any fixed rate loan, unlike a credit card. Credit cards might be fixed rates, but you can adjust the balance by adding or subtracting to it. Whereas typical loans like cars, homes, boats, anything like that, you're only subtracting the balance over time to ultimately pay it off. This is a big, hairy, crazy formula. It's got a negative exponent. That complicates things. Complicates them quite a bit, in fact. Why do I have the same page twice? That's weird. So this formula, what the guided activities want us to do ultimately is what formula is entered in cell E2 using these these 4 cell references. So this yellow highlighted number right here, this 289.99, this is acquired by using the 15,000, the 6%, a monthly payment system, compounding system, and then 5 years, all thrown into this formula right here. But they want to know what it looks like in Excel. Let me just kind of back out. I'm sorry that this is a little tiny. That is a negative nt is the exponent, but I just want to be able to have all this on the screen to show you what it looks like. This is the answer equals. So the P times APR over N, you have to put a parentheses for that. Then the negative NT, because the exponent's a little more complicated, you'll have to wrap a parentheses around that, along with all the other parentheses you see. But that'll be good enough. So you go equals, open a parentheses, that's the black one I made. Then the principal. The principal is this cell right here, which is the 15,000, but the cell is A2. So cell A2 times. Then we're supposed to take the APR, which is in cell B2, so B2, then divide it by the N, which is in cell C2. And then we will close that parentheses, because that's the whole top of the fraction, slash for the fraction or the division, open a parentheses, 1 minus, open a parentheses, 1 plus. That's literally just this stuff right here. APR over N, cell references again, that's the B2 over C2. Then we'll close that because that's all of the denominator. Except for the exponent part. But since the exponent is complicated, we go parentheses after the caret, negative, but NT, the N was C2, the T was D2, so C2 times D2. You close the parentheses for the exponent part, then you close the parentheses for the entire fraction. So I'm not asking any of you to do that. We will not have any homework with a crazy complex formula like that for a very long time. The previous answers are pretty clear cut and dry, 1, 2, 3, and 4. These will be also part of your discussion board. So that's page 39, 1 through 4. Again, 1 student each. 1 student each. So page 39, questions 1 through 4, but not 5. So I got to clear my screen. I got to come off of annotate. So discussion board. And then page 39. The other page was 37, by the way. I'll have all this on the screen at the end. So 39, 1 through 4, 1 student each. That's 9 opportunities. Remember, you don't have to answer a discussion board every single time. If I only have 15 potential answers and they're all right on the first try, not every student gets an opportunity maybe, but that's okay. There's plenty of other opportunities. You don't have to do every single one. All right, taxes is next. The BMI was next. Where's my next page? That's fine. Okay, we're good. All right, back to our notes to share. Simple solving of equations. This is just basic algebra reminders that we should all be capable of. Again, this is prereq material. Practice if you're rusty with your algebra. With solving equations, the main idea is whatever you do to one side, you do to the other. And you always work in opposite operations, where addition and subtraction are opposite operations, and then multiplication and division are opposite operations. So for example, if we had 2x plus 3 equals 5x minus 7. The goal is to get x solved for itself. Again, this has nothing to do with Excel. This is just standard math that you'll have to do every now and then in here. You got to get the variables on one side, the constants on the other. So, does it technically matter if you move the 2x or the 5x? No. Me personally, I prefer moving the smaller one, but you can certainly move the 5x. It just means you'll have a negative variable that you'll have to divide out in the end. So I want to move the 2x, so I'm going to subtract it because it counts as being positive. It counts as being added. And it's not because of this plus sign. This plus sign is not why I'm subtracting 2x. It's because there's an imaginary plus sign here with that 2x. That's why we subtract it. Doing so will give us the 2x's cancel, so we get 3 equals. 5x minus 2x is 3x. Bring down the minus 7. Make sure you're keeping your notation accurate. I don't care if you're showing your work horizontally, vertically, or not at all. Just be capable of doing it. Now, since the x is on the right, the 7's got to move left, so we need to add 7 to both sides. And you might say, why aren't you dividing by 3? I'm going to save that for last because it's easiest. Technically, I could divide by 3 in this moment, but it complicates things. 3 plus 7 is 10 equals 3x. The 7's cancel. Then we divide both sides by 3 because that's 3 times x. We are not subtracting, we are dividing. 10 divided by 3 does not divide out perfectly, so I'm actually just going to leave that as 10/3. The 3's cancel on the right, so 10/3 is our x. That is also 3 1/3 or 3.3 bar, but you could not say it's 3.3 unless it told you to round. It'd be 3.3 with a bar over it. So that's 3. What happened? Where did my pen go? Why aren't you working? There we go. That's 3 1/3 or 3.3 with a bar over the 3. But if I did this, that would be wrong because that's a rounded answer. Now, if they told you to round, that's fine. But if they don't tell you to round, you better not round. All right. I'm thinking. Yeah, this is really short. We got time. 1.3. 1.3 is the shortest notes to share. There's not a lot going on, but I do want to go ahead and get the discussion board up for it. That way it's not just 9 answers. So the good thing is we can go ahead and just quickly talk about this and then go straight to page 44, 45. Just 45 technically is needed, but 44 sets it up. This payment formula, this is the Excel version of what you saw earlier. You still see on the screen right here. So this is the Excel version without the cell references. It's using the letters, and you can see that the parentheses are set up exactly as they were before I had to erase the screen. Again, this is above our pay grade for now. This is something we'll see in chapter 9, but for now, I'm just showing you an idea on how more complicated mathematical expressions, functions, formulas, whatever you want to call them, can be placed into Excel ultimately. But for now, we're keeping it a little simpler. This is really just a reminder, again, technically, but just to be safe. If you're ever asked about domain and range in my math lab homeworks, I don't really test on this, but domain is how far left or right a graph goes, and range is how far up or down it goes. We did discuss previously that the domain is your list of inputs, your range is your list of outputs. Domain relates, or inputs relate to the X values, range relates to Y values for your traditional math things. We don't always have Y's in here, and they're not always X's in here. But in terms of your standard rectangular coordinate system, your X values go left and right, aka your inputs go left and right. And then your outputs, your Y's, your domain, I'm sorry, your ranges, they go up and down. And then this is just something that is a constant issue throughout the semester. Pay attention to where your units are. I'm not going to get too heavy-handed into that right now, but this is going to become a constant issue once we get into chapter 3. What do I mean by where the units are? I traditionally mean whether they're in the top or bottom of a fraction when we see numbers with units. So this is just kind of foreshadowing for now, but it's a good idea to go ahead and get used to paying attention where units are. For instance, like this principal, the dollar symbol would be in the top, not the bottom. This percent symbol would be counted in the top, not the bottom. If I had something like 3 inches, that inches counts as being in the top, not the bottom. Versus, say, if I had 3 on top of 1 inch. These are completely different things. Having an inch and a top, this is our traditional idea, 3 inches. This in the bottom, the second case, is actually 3 per inch. That's what that second case means. The left one is 3 inches, the right one is 3 per inch. So whenever you have units in the bottom, it means there's a per involved, P-E-R, not like the cat sound. And this is going to be a common theme for many, 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 many months once we get into chapter 3. Not as big of a deal for now, but a major, major issue moving forward. So I mean, really, that's all I have to share for 1.3. Just a couple of minutes. It's nice and quick. But we can go to the guided worksheet, not out, in, not that far in. There we go. Mouse wheel got a little excited, didn't it? These definitions in 1.3, and here's those cash symbols again. So I've littered this all over the place. It's in your textbook, which I didn't show any of today really, because I didn't feel it's necessary, but you can still go through and look at it. It cross-references 1 or 2 things from these guided activities per usual. But this idea of what we call what-if analysis, you're going to see me talk about this in the next class a little more. But what-if analysis enables you to go through lots and lots of scenarios of things. All right, so I'm going to go get a car loan for 5 years and it's a 5% car loan. But what if my credit was a little better and I could get a 4% loan? Or what if my salary was a little better and I could take a 3-year loan and be able to pay it off? Or what if my salary sucks and I got to get a 10-year car loan? Or what if my credit is trash and I got to get a 10% loan? So you can go through all of these options. A lot of people think, oh, when I go buy a house or a car, I got to go talk to the loan officer to find out what my payment's going to be. I mean, you might need it for the exact number, but you can get a ballpark number really easily if you understand your credit score, if you know what the common rates are for good or bad credit scores, and you can just plug them into that formula we saw earlier. But very often in these what-if analysis, you'll be using Excel because you'll be going through dozens or hundreds of scenarios. And very often in those, you'll need to be using these mixed or absolute or relative cell references. You might need cash symbols sometimes. Sometimes you don't, sometimes you do. Sometimes you got to fix a column, sometimes you got to fix a row, sometimes you got to fix both. So again, very helpful reminder, pretty much the same language we've seen already. But yeah, what if analysis? What if I borrow more money? What if I take out 17 grand instead of 15 grand? You know, maybe the car costs 17,000, you've got 2 grand in your pocket, and then the dude says, hey, you don't have to put the 2,000 down. We'll let you take the 17,000 loan. You go, well, you know, that'd be nice so I could sit on this $2,000, but then my payment's going to be higher. The more you borrow, the more you pay. The longer you borrow, the more you pay. The higher interest you borrow with, the more you pay. Those are all positive correlating factors. And we'll talk about that idea throughout the semester. So the point of this is, okay, we start out, we had that $15,000 loan at 6%, paying it off monthly for 5 years. It ends up giving a payment of $289.99. We saw just this section alluded to earlier, just, let's blow it up. We saw just this section alluded to earlier, and you have 4 discussion board questions related to it. The answers are pretty much staring you in the face. Now what we're going to do is open this up. Instead of just that one scenario with 4 values, let's go through a different series of APRs and a different series of amounts of time. And let's see what our payment would be if we took a 1-year 1% loan. It turns out it would be $1,256 and some change. What if I took a 6-year 10% loan? It turns out you're paying monthly $277.89. Again, monthly. This isn't your total payment. This is your monthly payment. So you might go, wow, I don't want to take a 1-year 1% loan paying $1,200 a month. That sounds awful. I want the 6-year loan, and I'd rather pay 10%. I'll even take the higher interest rate because it's $277 a month. Well, no, I mean, that sounds better on a month-to-month basis, but you're paying this one off in 6 years, whereas you're paying this off in 1 year. In other words, you're taking 6 years, 12 months, that's 72 months, versus 12 months in the 1 year. So you're paying this $277.89 72 times versus this $1,200 only 12 times. Also, I can guarantee you, you're definitely paying more for the car the more interest you pay. In fact, the absolute cheapest scenario up here at the end of you paying off your car is taking the 1-year 1% loan. Now, am I suggesting that's what you do? Not necessarily. It's really rough paying $1,200 a month for a car. We like to be in like the 300 range or less, maybe just a little more, you know, if we are taking a car loan. Me personally, I'm anti taking a car loan. I'm not into new cars. I'm not into financing things if I don't have to, but that's my own personal beliefs. And I'll give you logic and reasoning ultimately as to why I have those beliefs by the end of the semester, but I will never tell you what to do. I just tell you how to do things if you want to have more money in the long term. So this is where we're getting to our discussion board, and we're going to close out with this. For question 1, what are the 2 specific inputs, APR and term, for the highlighted payment of $456.33? So for this one, what APR are they using to calculate this, and what length of time? That's what they mean by term. How many years for that highlighted payment? So this is really easy to figure out. I've already kind of alluded to this idea with the multiplication table, but I don't want to super spoil it right here. But being in this position tells you exactly how long and at what APR you're financing. This yellow position would be different for one of those values, but not the other. Number 2, you're going to skip because that would have that crazy formula I wrote down earlier on hand, but there'd be cash symbols in there as well. And I'm going to skip that. Question 3, how much total interest is paid with the $289.99 monthly payment? So question 3 we will be doing. I'm going to give you a hint. The answer is in the 2,000 to 2,500 range. That's the only hint I'm going to give you with question 3. How much total interest is paid with so let's say you took the 289 payment. So 289 payment, that gives you a certain number of years you're paying it and a certain APR you're paying it. But we don't really need to know the APR. All you need is the years, because I gave you some formulas in the chapter 1 notes to share, and they were bolded, and we said they were super important. How do you find your total number of payments? Take the number of payments times the loan term. How do you find the total paid? Number of payments times payments. So you'll be using those. How do you find total interest? Take the total you pay minus the principal you borrow, which was that $15,000. So you'll have 3 steps. So total paid and total interest. The total number of payments has to be done first, but that feels like a more implicit step to a lot of students. So that's how you get question 3. You'll have to go through those 3 formulas, if you will. Question 4, how much would you save in interest if you switched to a 3-year loan? So they give you the answer for how long and what APR this is, which basically tells you how to do the one for the blue box from question 1. But what if we switch to a shorter term loan? Going to a shorter term loan, spoilers, you will save money. So you'll have to, someone will have to do the exact same calculation that they did for question 3, but this will be another student. But now instead of using 5 years 6%, they're doing 3 years 6%. So you'll find the payment in the 3 years 6%. I'm going to point at a wrong one. This would be a 1 year 5% in particular. That's not the one you use. So you find the right payment amount. You multiply by the number of payments. You'll subtract that amount from the principal to get the interest. But then they say, how much do you save? So let's say the answer is number 3, that the interest was just $1,500. It's wrong. Let's say the interest for number 3 was $1,500. And let's say the interest for this scenario right here was $1,000. If this one costs you $1,500 in interest and this one costs you $1,000 in interest, that makes the savings $500, the difference of the $1,500 and the $1,000. Again, not the exact answers, but that tells you how to do it. Question 5 is basically the same thing as question 3, but it tells you which scenario to look at to find the payment. Question 6, your answers are going to be both, row, neither, or column. So spoilers, this one's both. There is not another one that's both. So this answer might be row or column. This answer might be row, column, or neither. This one might be row, column, or neither. This one might be both. I've already said it's not, but that's what we're doing for question 6. 1, 2, 3, 4, 5, 6 of those. So for the discussion board, we're skipping question 2. So it's just 1, 3, 4, and 5. Sorry, 1 and then 3 through 6. And I actually want 1, 2, 3, 4, 5, 6 students to do number 6. So that's going to finish us for the day.
All right. So if you have any questions, as always, you can email me. You can see what we have on the docket for our due dates. As we said before, remember, you can review your Excel stuff. We did finish 1.2 and 1.3, so those will be due in a week. 1.1 is due on the 31st. That other discussion board is also due on the 31st. Your Excel is due on the 31st. There'll be another Excel assigned next time. I'm not going to assign the next quiz until a week from today. So you'll see, and it's going to be a video quiz, and we'll talk about that when it's appropriate, but just letting you know what's ahead. So everyone have a good day, have a good weekend. Hopefully the snow doesn't mess us up too much over the weekend. We keep getting this this snow. It's fun for some, not for others, but hopefully you get to enjoy it if you enjoy it. All right, take care, everybody.